Okay, let's do this question called assign cookies. Assume you are an awesome parent and you want to give your children some cookies, okay? But you should give each child at most one cookie. Each child I has a greed factor G of I, which is the minimum size of a cookie that the child will be content with, and each cookie J has a size J. If the size J is greater than the greed index, we can assign cookie J to child I. The child will be content. Your goal is to maximize the number of your content children and output the maximum number. Dude, my lungs are like fucking busted. I sparred the week before this and today, and I'm just like fucking done. Gee. Okay, so there's greed factor, and then there's sizes of the cookies. Okay. Greater than or equal to. So for example, we have 1, 2. There's only 2 children. G and their greed factors. 2 children, 3 cookies. The greed factors are 1, 2. So if S's length is 0, S's length len S equals 0, return 0. Because you don't have any cookies, so you can't satisfy any children, and you'll have a G length of 1 at minimum. So we need to at least make sure the S length is greater than 0. Second, this is kind of like one of those 2-pointer questions. 1, 2, 3. So what I'm going to do is I'm going to sort. Are these pre-sorted? I don't know if they are, but it looks like they are. So they're all pre-sorted, it looks like. Factor, content, your goal is to maximize the number of children cookies. Okay, so what I'm gonna do is I'm going to get the length of S, or the length of the kids, the greed factor, the kids, greed factor, whatever the fuck. So length of G equals, I'm going to call it Glen. Glenn from Walking Dead. So we call this Glen. The other one I'm going to call what do I want to call this? So while yeah, it's already pre-ordered, so I'm just gonna go while Glen and while I could go the index. Glen is len G, is len of G. So that's the number, that's the total number of kids with the greed index. If we hit 0, we satisfy all the kids. Output equals 0, so while Glen is greater than 0, and S, so we gotta also create an index for S, so S is gonna be len S minus 1 S index equals len S minus 1, and then I want to make sure that is also greater than or equal to 0. So basically what I'm going to do is, since it's pre-ordered, I'm just going to start at the last index and see if I can match it to the last index of the kids with the greed index. S index, and then I'm going to create a G index. Oh, I could just go g.pop and it'll remove the last index. Okay. So let's give that a shot. Oh, it's the minimum size of the cookie. Okay. So S index is 0. Len S minus 1. So if S at S index 0, if S at 0 is greater than or equal to and then let's go G index is also 0. Neither or array ends, it ends. and then we return output. S index is greater than or equal to, oh yeah, the G index, the greed index is 0. Output plus equals 1 first and foremost. One of them is going to end first. The other thing is, if the S index, it goes according to the greed index. Unless you satisfy the kid, the S index has to keep going. So if the S index is greater than or equal to, and they both start at 0, increase the output. S index plus equals to 1. S index plus equals to 1. The other one is G index. Yeah, then we could satisfy this G. Add 1. Else S index plus equals 1. Then we compare the new S index with the current G index until it's over. So we can do that. And then, yeah, we get the output once either or is finished. So we run that. Well, that's invalid syntax, len s equals 0. If boom, wrong answer. 15 out of 25 test cases. Okay, so S G is 10987. G is 10987. S is thing. Okay, so then all I have to do here is sort them. Because of the two examples, I assumed they were sorted, but they're not. So G dot sort S dot sort. That should solve the issue. Yep, pass the test cases. There we go. Beats 22.25%. So what I did was basically, I know that I have to satisfy, I only get an output, I can only get an increase in output if a kid is satisfied. That means these cookies have to be the right size, right? So I have to keep going through the sizes until that kid is satisfied at some point in the size array. So for example, since the size is 1 and the first kid's greed index is 1, it satisfies the kid, right? Then I increment both. Now I go to element 2, greed index 2. 2 is bigger than 1, so the kid won't be satisfied with this. So then at this point, I go s index plus 1, and it's greater than the length of the array. So it breaks out of this while loop, and we only get 1 as the output. Output equals 1. For this, we trace it, so we go 1, 1 satisfied, 2, 2 satisfied, 3, 3, but because g index also incremented to 3, it's greater than the array, so you only output 2. See what's going on? And it only works though if, so one of the clues here was this works easily if both arrays are ordered. And you have to satisfy, which is the minimum size of cookie that the child will be confident with. So if we want the minimum size, the best way to start is with the kid with the minimum greed index. So I have to sort these two arrays, and that way we can just go minimum, minimum. Does it match? No. Next, match? No. Next, match? Yes. Okay, boom. Now we go to the next kid. Match? No. Match? No. Oh, I'm out. And depending on the array size, all we have to do is keep matching until we hit the end of either or array. And then we just spit out the output. So as you can see, I passed the test cases, I passed the submission, and it beats 22.25% of solutions. So if you like this video, please give it a thumbs up, subscribe, and comment below. Knologist out.